Hi, I'm Vijay. I'm a PhD student from School of EDMS. My research is towards automating laboratories for engineering distance learning. We are quite familiar with the term distance learning, where the student and the tutor are separated by distance, and generally the learning takes place through online communication tools. Okay. Which you go. Okay, when it comes to engineering, laboratory plays a very important role. Further, for courses like mechanical and automotive, practical skills are said to be really vital. So there comes a challenge in how to impart and assess this skill in a distance learning environment. Lots of researchers have looked in different aspects for this challenge. The one such aspect that we look is it's the transition of the learner. Since it's a distance learning, lots of learners are from different domains. They may have experience, they may be working in an industry, or they may have zero knowledge. So measuring the transition is really important. In an on-campus environment, generally, a tutor comes in and he observes the way the students do their practical and assists them and provides them feedback according to their actions. It's something like this. He observes them and he has the checklist in his mind, whether he has to stop them or whether he has to allow them and say what they have gone wrong at the end. So taking that into consideration, okay, how to measure this transition? We should have we came up with an assessment axis, which generally has a level, depth, and rigor axis. In here, level indicates the complexity of the task. The depth indicates the depth of knowledge that the student should impart in completing the task. Rigor is the output, which measures whether he has done or not. Each of the learning object consists of this axis. When it comes to a learning object, let's consider for an instant welding. Welding as a practical task has its own level, depth, and rigor axis. When we break welding, it has sub-learning objects, something like T-joint, flat plate, saucer, weld. Each of those have their own level, depth, and rigor axis. When we once again split those one among the sub-learning objects, like let's take flat plate, and that will have its own sub-learning objects like health and safety for that, procedure for that, what's the preparation, and what's the execution. Okay, let's consider, okay, we have to automate this assessment in a virtual environment. How we could automate? That's the primary focus of the research. The tutor's knowledge is one of the most important one. How to capture this tutor's knowledge and how to model. We have adapted an KB technique which is being used in manufacturing industries to capture and model the knowledge for automating manufacturing process. Generally, this captured knowledge then automates and feeds the AI system, which is the artificial intelligence system, which acts as the tutor in a virtual environment, where the automated AI systems then feeds into the transition, which it measures what the learners are doing. Are they doing correctly? If they need some help, okay. If they need some help, what should be the help? Should I stop him now, or should I give him more feedbacks, or should I come back again to him? So that's how this works. When you see in here, so the artificial intelligence, which has the knowledge of the on-campus tutor, which is being captured and modeled, it feeds in and it automates the assessment axis that we were talking. Okay, how the knowledge capturing took place? It's pretty straightforward. It's each and every aspects in a practical task. How they do, what are their actions, what could possibly go wrong and right as well. These are some of the screenshots that when we capture the knowledge. So this is a measurement. It's generally a practical task that involves welding two flat plates. Those are the measurements, the angle, then the hand speed, how much is the speed, the impact factor. Even in welding, according to the tutor's knowledge, one can say whether it is a good weld or he's going too fast or too slow with the sound. So even those are knowledge. So these captured knowledge then feeds the AI in teaching the student. So once the knowledge was captured, these captured knowledge were modeled in an ontological structure, which has classes, subclasses, individuals, and rules. Okay, when we talk about rules, when we talk about AI is something which is not only about the knowledge that's been captured. The rules happens to be to generate the new sets of knowledge. So it gives potentially to develop the new knowledge by doing in this form. Those are the knowledge capturing that we have done, and this is how the knowledge was modeled through ontological structure, which has classes and which has subclasses, and those subclasses has their own individuals. Individuals are associated with the rules in automating the AI systems. Okay. So how to bring everything in a virtual environment? So we need to have a framework. In our framework, we have 3 blocks, which has AI tutor, assessment block, and the environment. AI tutor consists of the captured and the model knowledge of the on-campus tutor. The assessment block, which assists the transition of the student and provides them feedback. The environment is the place where the student perform their practical activities. In here, we use our environment as Unity. Unity 3D is one of the popular game engine, which has potentially different add-ons for new technologies. So which triggers AI? What triggers AI? Generally, the instance that takes place in the environment. So when a student is doing some activity, those are the instance which is from the front end. That instance triggers the AI which goes into the backend. So whenever he does some activity, whenever he performs something, it's been monitored by the AI in providing him feedbacks. And also the rules, whatever knowledge, maybe we can't capture all the knowledge. So if there is some new instance that is not being captured, that will be captured by the rule which forms as the new knowledge. We have a sample of what we are heading towards. So you can see a robot walking. This is the environment of our mechanical lab, and we are now concentrating on the welding aspect. So a student who's walking to the welding is being populated with the learning objects that's with the welding task. In here, okay, there is a welding. Welding has subtasks of flat plate, T-joint, and saucer. So there is the learning structure. If he wants to learn that, he can see about it. Somebody can tell him about it, and he can have a go. Have a go is the real-time environment where he's been monitored by the AI system. And that's it for now. Thank you.